Hey kids, Miss Kulkarni here. In this video, we will talk about liquids and solutions. And there are some commonly used terms. Let's learn those first. One of the important terms which we have, which we always use, is IMF, which is simply inner molecular force. So liquids do have those IMFs. Keep in mind, if you want to compare solid, liquid and gas, these forces decrease from solid to gas. Let's think about the next one. Liquid molecules, they are quite close together. Again, if you want to compare solid, liquid and gas, they are very close, tightly held together in solid. In liquids, they are close but not as close as solids, and of course in gas, they are far apart. Next one is liquid molecules. They are not able to compress and expand it to what? To any measurable amount. So they may, but it is not to that much quantity that we can measure it easily. Liquids are fluid, that means they can flow and they can also diffuse into each other. About the shape, very important thing to remember. Solids do have a definite shape, but liquids don't have a definite shape. They simply take the shape of the container and they won't expand to fill it. Liquids are less dense than their solid counterparts. Now remember, this is true for most of the liquids, but not water. Water is exception. So what happens in water? Density of liquid water, if I want to consider liquid water, and if I am comparing that with density of solid water, which will be ice, then density of liquid water is more than density of ice. So that means ice can actually float. So this is floating ice on the top of lakes and oceans. And then what happens with that? Because there is ice cover on the top of lakes, underneath here there could be aquatic animals like fish. They can still survive. Let's move on to some other terms. There is cohesion and adhesion. Cohesive force or cohesion is because we have some strong intermolecular forces which is between the same substances. So water forms a continuous flow because of the cohesive force. We can simply use the word that the molecules stick together. What about the adhesion or adhesive force? This is the attraction of liquid with other substance. Like maybe liquid is sticking to glass. That is called adhesive force or adhesion. There is also something which we need to remember is capillary action. And when both these cohesive forces and adhesive forces work together, that may lead into something which we call as capillary action. Here is one more term, which is vaporization of liquids, which means liquid turning into vapors or gases. This can happen with two processes. One is boiling and the other is evaporation. So what's the difference? Boiling takes place only at a particular temperature, which is boiling point, and evaporation can take place at any temperature, even below the boiling point. Okay, how is the process of vaporization? We classify that as an endothermic process. The word endothermic has two parts: endo, which means in, and thermic or thermal, which means heat. So when heat is taken in, that's called endothermic process. Basically, heat supplied will result into vaporization. Now how exactly that works? The heat energy which is supplied or which is taken in by the system actually weakens the IMF, the forces which hold the molecules together, and then with that molecules can escape and we get vaporization. Now again, keep in mind, evaporation can take place at any temperature. It will be always happening to some extent, and that means every single liquid will also have vapor pressure. And then also keep in mind, as the temperature increases, the vapor pressure of liquid will also increase. Now how does it matter? It does matter because evaporation rates are directly dependent on IMFs. So let's compare water and acetone, for example. And we all know that acetone evaporation rate is much faster compared to water, which is slow. This can evaporate just in a matter of few seconds, whereas water will take a little longer time. Why is that? IMF strength for water is stronger. They are stronger forces. And in acetone, the forces are weaker. Now, what kind of forces water has? Remember, water formula is H2O, or if you really break that, it's H and OH. That results in hydrogen bonding. And hydrogen bonding are quite strong IMF. Whereas for acetone, the only IMFs which work are simply London dispersion, which are quite weaker. So in a way we are telling that the type of IMF will decide the rate of evaporation for a particular liquid. Let's talk about something which we call as equilibrium. Equilibrium is when nothing is moving in any direction. So if the rate of evaporation is equal to the rate of condensation, practically we don't have liquid converted into gas or gas converted into liquid, and that we call as equilibrium. In a closed system like this, it is possible to have both liquid and gas in equilibrium. Now let's talk about some important concept. As we go to different elevation, it will have the effect on boiling point of liquid. There is something which we call as a normal boiling point, that is always at a pressure of 1 atmosphere, and when we are doing the experiment at sea level. Now keep in mind that when we go to higher altitudes, the atmospheric pressure decreases. It will be less than 1 atmosphere. So if it is less than 1 atmosphere, then it does not require much energy to get that pressure for vapor equal to pressure of air. So what does it mean? The boiling point will be lower or less than the normal one. So the boiling point of water is 100 degrees at sea level, but maybe at Mount Everest it may be lower, as low as maybe even could be 70 degrees Celsius. So this picture kind of tells you how the boiling point and elevation are related. So this is altitude, and if altitude keeps on increasing, this is the boiling point. Boiling point keeps on decreasing. I hope you guys enjoyed the video. I will see you in next video. Until then, bye bye.